Here we have a sad math question. There is an equation given here. That is 7th root of x to the power of 5k negative 1 equals to x square over 7th root of x to the power of 11. In this equation, we have to find the value of k. Okay, so to solve for k in this equation, my first work is to get rid of the 7th root. We have over here and here. So for that, first what I need to do is I have to write this 7th root as an exponent. So how can we write this 7th root as an exponent? So whenever I write a 7th root as an exponent, the exponent will be 1 over 7. So now let's consider the stuff we have inside the radical, that is x to the power of 5k negative 1. So for this stuff we have 7th root. So I'm going to write this 7th root as an exponent. Then the exponent will be 1 over 7. And on the right side we have x square in numerator, and in denominator for this x to the power of 11 we have 7th root. So we can write this 7th root as an exponent. Then I'm getting 1 over 7. Okay, now to get up the exponent 1 over 7 here and here, what I need to do is I have to raise both sides of this equation by to the power of 7. So now let me raise the stuff on the left side to the power of 7, on the right side also to the power of 7. Okay, now let's consider the power of a power rule in exponent. That is, let's consider the base a with exponent m, and let's consider another exponent n for the completes of a to the mth power. So whenever we have two exponents like this, what can we do? We can multiply the two exponents. Then I'm getting a to the power of m times n. And also let's consider a over b whole to the power of m. So here we have a fraction and we have common exponent m. So whenever we have a common exponent for a fraction, what I can do is I can take the exponent m for numerator and denominator separately, divide them. That is a to the mth power divided by b to the mth power. So first I'm going to use this property of exponent on the left side. So because here, so the exponent 1 over 7, and for this complete stuff, we have the exponent 7. So what can we do with the two exponents? We can multiply them. So let me do it in the next step. That is x to the power of 5k negative 1 whole to the power of. So I'm going to multiply these two exponents. That is 1 over 7 times 7. And here 7 is a common exponent for this fraction. So we can take this exponent separately for numerator and denominator. So when I do so, I'm getting x square whole to the power of 7 over x to the power of 11 whole to the power of 1 over 7 whole to the power of 7. So I've taken this 7 exponent separately for numerator and denominator. So when I multiply 1 over 7 and 7 at the exponent over here, this 7 will cancel out. So and we just get exponent 1 over here. Whenever there is exponent 1, we can ignore it. We don't have to mention that. Okay, let me continue the problem over here. I'm getting x to the power of 5k negative 1, and we don't have to mention the exponent 1 over here. So we can leave it and equals to, so here let's simplify this stuff. So already we have discussed the stuff and property, the properties of exponent over here. So whenever we have a to the mth power whole to the nth power, we need to multiply the two exponents. So now this x square whole power 7 is in the form of a to the mth power or to the nth power. So what can we do with the two exponents 2 and 7? We have to multiply them. So I'm getting x to the power of 2 times 7 over, again the same thing. So we have exponent 1 over 7, again we have exponent 7. So we can multiply the two exponents over here. That is x to the power of 11 whole to the power of 1 over 7 times 7. So the 7 will cancel out. So I'm getting x to the power of 5k negative 1 equals to x to the power of, when I multiply this 2 and 7, it's 14. So here the exponent is 1. We don't have to, whenever the exponent is 1, we don't have to mention. We can just consider only x to the 11th power. Okay, now x to the power of 5k negative 1. Okay, now let's consider the quotient rule of exponent. What is the quotient rule of exponent? For example, let's consider a to the mth power divided by a to the nth power. So here I divide two terms with the same base. Whenever I divide two terms with the same base, what I need to do is I have to take the base a once and I have to subtract the exponents. Then I'm getting m negative n. Okay, now the stuff we have over here is in the form of a to the mth power divided by a to the nth power. So the base in the numerator is x, the base in the denominator is also x. So we divide two terms with the same base. So what we can do is we can write the base once and we have to subtract the exponents, that is 14 negative 11. So x to the power of 5k negative 1 equals to x to the power of, when I simplify this one, 14 negative 1 is 3. So here two terms are equal with the same base. The base on the left side is x, the base on the right side also is x. So whenever two terms are equal with the same base, what we can do is we can equate the exponents. That is 5k negative 1 equals to 3. Okay, our aim is to solve for k. So let's add 1 to both sides. When I do so, this negative 1 positive 1 will cancel out. I'm getting 5k on the left side. On the right side, when I add 3 and 1, I'm getting 4. Okay, now let's divide both sides by 5 to solve for k. This 5 will cancel out. So k equals to, when I divide 4 by 5, I'm getting 0.8. I've solved for k. So the value of k is 0.8.